Hi folks, in this short video I just want to take a few minutes to explain to you the important concept for area of a regular polygon. I think in this lesson in 10.2 you also have area formulas for circles. Those are pretty easy. Area of a regular polygon, also fairly simple, but this is going to be new for you, and so it's worth walking through. In this first video we'll just walk you through why the formula is what it is, and there's a new word here that you'll learn. The book defines it, of course. And that word is apothem, A-P-O-T-H-E-M. All right, so on my board here, I have a couple things set up for you. So the formula, we'll start with that. The formula for area of a regular polygon, and of course, pay attention to that. This is just for regular polygon, okay? Not for irregular, but for regular, meaning all sides congruent, all angles are congruent. But the formula for a regular polygon is area equals 1/2 times the apothem, little a is for the apothem here, times the perimeter, okay? So again, capital P is always perimeter, or almost always in geometry, capital A, area. Lowercase a here is gonna be this word, the apothem, okay? So let's talk about what the apothem is. And I've drawn here a hexagon. A hexagon is a good example to work with. In the next video I do, we'll do an area of a hexagon, because a hexagon, the numbers are so clean with central angles. We'll get to that, okay? Hexagons are particularly good for examples, okay? What the apothem is, okay? Every regular polygon has a center, okay? A direct center. That center is going to be equidistant from each of the vertices, okay, of the polygon, okay? So capital letter C sometimes for that center, okay? But what the apothem is the altitude, perpendicular height, okay, or altitude from the apothem to any of the sides, okay? So that's gonna hit at 90 degrees there. That is your apothem, okay? And so why is this kind of important, okay? Well, I want you to see what's kind of going on behind the scenes. And remember, so many things in geometry have to do with triangles, okay? If you've got a regular polygon, you can essentially divvy up the polygon into a number of congruent triangles. And that number of congruent triangles is going to match, of course, the number of sides, right? So you've got a hexagon, 6 sides. You're going to have 1, 2, 3, 4, 5, 6 congruent triangles. So the idea here is if you can find the area of just one of those triangles, then you can effectively know the area of the whole polygon just by multiplying by the total number of triangles there are, which is the same as the number of sides. So let's focus on just the area of one triangle, just one triangle. So let me take a second and erase all these spokes here. So we can just focus on the area of this one triangle. So when you're doing these problems at home, usually what we do is we kind of sketch out this one triangle, okay? And then in fact, we'll get to this in another video. We really just sketch out the right triangle, which is half of that one triangle, but we'll get to that in a second. For right now, let's just consider or ponder, what is the area of this one triangle, okay? Well, let's call this bottom of it, this base here, okay? Let's call that an S for a side, okay? Right? Usually S is a side in a polygon. And we know that the area of a triangle is 1/2 base times height, but let's substitute some letters in. Instead of the height, we're using the A, the apothem, right? So instead of an H, let's put an A for our apothem. And instead of the base, let's put an S for side. So 1/2 A times S, okay? That's the area of that one triangle, right? Now, how many of those are there? Again, there are 1, 2, 3, 4, 5, 6, hexagon, okay? So if we do all the triangles, let's do a little magic here. We do all the triangles, okay? Then we would just multiply all of that by 6, okay? Now, consider that 6S here, 6 sides is a what? 6 sides is the perimeter, right? P is 6S. So do a little substitution and you have it, A equals 1/2 times the apothem times the perimeter, okay? So we'll give you that formula on any quiz or test. Okay, but try to memorize it. It's fairly simple. But I just wanted to do that video to explain to you why that formula is what it is. It's all based on the fact that you have a number of triangles in a regular polygon. Okay, thanks. Hope that helped.